Hi, this is Amy Lewis with Cisco Marketing, and we're here on Engineers Unplugged. It's a tale of two Andys. I finally have people who have the same name and are height appropriate. It's a dream for any executive producer. So we are talking today about BYoNetwork. It could be build your own, it could be bring your own. So Andy Sholomon, Andy Banta, thanks for being here, and I'm going to let you take it away.
Well, thank you. Andy was telling us about the network they built for his house, so tell us about it.
So I actually live in a very rural area, and there really isn't any wired network connections to it. For the first few years that I lived there, actually I just used 28K baud modems, and that worked up until the mid-90s, and at that point I simply started to need more bandwidth. So what I did was I actually got 4 phone lines.
I didn't want to tell him why he needed more bandwidth.
Everybody knows why you need more bandwidth. So, and I had some friends who lived in town, and I had a T1 brought in to that side, and I ran an Ethernet off here. And I used Cisco 2509 access servers to multiplex across 4 phone lines. And that gave me roughly ISDN speed, which was fine for the mid-90s through 2003, 2004. At that point, even that was a little bit slow for the type of work that I need to do for my job and for just the normal internet bandwidth. So ran into a guy who actually had started putting together an idea for a wireless network out to our area. So let me draw you a rough map. I live in a fairly large valley, and there's a mountain range here. And he lived over in Civilization, and he actually had a T1 coming into his place. So what he originally set up was that he found another person who lived up on the mountaintop. He ran a wireless link to that person, and then ran a point-to-multi-point wireless access point. And I, out here in the valley, was one of his customers. So that worked fairly well. It was actually using some 1.5 megabit old, actually Israeli networking communications, and it was good enough to start with. So as time went on, he started to realize that maybe he needed some additional ways to get bandwidth in. So he got a cable connection in and scrapped the T1. And at the same time, he started building out into a valley that was over here, and found that Sprint actually had a cellular connection right at the edge of that valley as well, and that Sprint was willing to sell him some bandwidth there. So he actually built a connection here and started serving this area as well, and could switch back and forth between his 2 data sources. So if one of them went down, he had some redundancy. The problem was that sometimes there were links that went down, and that actually turned into a bit of a problem. So he found one more place up on the mountaintop, and jumped from this spot, the Sprint connection, and then to me, and that way there were redundant connections all the way around. This was an L2 network, and I was an endpoint of it. So if any one of these links went down, I could reconnect the L2 network and keep everybody connected if necessary. There was no automation in any of this.
Or as we call it, a cheap OC network.
Yes.
With a failover the other way. Or
Right.
FIDI, I guess. Maybe FIDI would be
Right.
another appropriate way of saying it.
I'll draw out our primary loop here in red. So a couple of years later, actually, I did find somebody else who had bandwidth coming off a mountain peak not too far away, and set up one more connection coming in. So in this case, we had a primary, a secondary, and a tertiary connection for getting bandwidth in and out.
This for you,
Thank you.
as your secretary.
Excellent. So the guy that was running the network would switch around traffic as necessary and allow and basically route traffic that was like video intensive or anything like that over the cable connection, because that was highest latency but also highest bandwidth. And these other two connections were a little bit lower, were much lower latency, a little bit lower bandwidth. And the nice thing was that there were also static IP addresses on them, so people who needed them for like VPN or more business-related services like me could use them. And off of here there were various other, so there are other subnets that come off of each of these and serve what ends up being about 200 people in this valley. So I was talking to the other Andy about what steps might we be able to take to make this more robust and more automatic failover, and he was telling me a few ideas. So
Now you hold it?
Yes.
Okay. So one of the things that Andy Banta was telling me about was that these are statically assigned IP addresses on their routers, and the customers point at each one of them as the service requires. But what they were having a problem with, or maybe not a problem, but a challenge with, was that if one of these goes down, the only way to get a failover would be for somebody like Andy to call up and make some changes and re-IP the boxes, or I guess from one of the customers just to point to a different IP address as their exit point.
Many
right?
of the customers weren't that sophisticated, so
Right.
actually typically what happened is that the routers, each one of these points would get the new master address, and
Right.
traffic would be shared.
And then we were just talking about the one idea I had was any first hop redundancy protocol, VRRP, HSRP, GLBP if it's a Cisco box, right? To kind of do the failover, meaning that if one box goes down, you'd automatically take over the IP address on another one of your routers. And as the box comes back up, you can take it back up. It's called preempting, right? And then we were talking about watching your own circuit. So if your cable modem circuit were to go down here, you could make that interface go down and one of its peers take over and then have the failover happen automatically. So that's one of the many things we could do. And also, I believe Andy was talking about using certain out exits for certain types of traffic.
Right. And actually, the service provider does do some filtering in these various different routers, and certain types of traffic will get directed to certain gateways out of the network. So, so things like Skype actually would go out some of the lower latency connections, and things like YouTube or Hulu or whatever would go out the fatter, higher latency connection.
Right. And then, so tell me more about the hardware. You were telling me that you guys bought some special boxes just to do this.
Well, actually, most of the routers in this network, and seriously, there are probably less than 100, but more than 20 routers, are router boards.
Okay.
Just very simple, very cheap, very easy to use routers. They're mostly military spec. They survive out in the desert where it gets up to be over 110 in summer and often below 0 in the winter.
Right. And another neat thing about this that Andy was telling me about was, these are some fairly long distances. So
Right. These are, just for example, this link is 8 miles. This link is about 8 miles. This link is about 6 miles. I'm not sure the length of this one. This one's about 2 miles, and this one's about 7 miles.
So at some point, you have to have some repeaters to work there. And Andy was talking about how an ingenious way that he was solving this problem, right?
For the repeaters?
Yeah. How are they getting the right of way for all these things?
Oh,
right?
well, yes. So actually, this person who set up the network goes and talks to the private landowners and basically tells them that they'll get free internet service if they are willing to be a repeater spot. And these two people on the mountaintops actually have antennas facing all sorts of different directions from them. And if you drive this guy by this guy's house on the way in town or whatever, you can see that he has about 5 different antennas pointed different directions, one for here, and some for various other purposes.
Right. So be your own service provider.
That's right. Bring your own network.
Okay. So this is completely fascinating. My question is, you have to be careful not to tick off your neighbor or no Netflix for you, is what I'm hearing.
Yes, but you'll notice that I'm actually first in line.
Viewers, do you think this is an accident? All right.
Absolutely not.
So this is completely fascinating stuff. Thank you guys for sharing this. And
So this is the Engineering Unplugged, jump the shark, right?
yeah, so they're going to jump the shark now. You know, what would you like to see? They are willing to put on leather jackets and surf over sharks.
At the end of the show.
Oh, are they going to do it? Is it unicorn time, everyone? It's unicorn time! All right, Andy Banta draws a unicorn. Okay, there's the horn. It's, oh, nice. I like the spiral pattern. I think someone's been practicing. Technique. Oh, wait. Is this a rainbow first? Yeah, all right. So unicorn, rainbow, so an invisible unicorn. Viewers, I should have learned my lesson by this point, but I never do. So once more, I have been outsmarted in the unicorn challenge. So thank you, Andy and Andy, and we'll see you next time on Engineers Unplugged.